Hi everyone, this is Pradeep Reddy. I'm the product manager for SageMaker Automatic Model Tuning, also known as the hyperparameter tuning service in SageMaker.
Awesome. Yeah, thanks so much for being here today. I know we've got people who are all different stages of their machine learning journey. There are probably some people who are experts, have been doing it for years, and I'm sure there are people like myself who are very new to it. So for those who are very new to the machine learning training process, can you just explain exactly like what it is and what are the actual steps that comprise of the machine learning process?
Sure. So it always starts with business understanding, right? Any machine learning problem that you want to solve, you really want to map it back to the business problem that you want to solve. So the practitioners looks at the business problem, then they look at the data that explains that business problem and the domain. They acquire all the data. Once they acquire all the data, they have to prepare the data for machine learning. So data in the raw format is not suitable for machine learning. So they do a lot of refining, curating the data. And once the data gets curated, enriched, blended with different dimensions, right, that's when it gets ready for machine learning. Beyond this data preparation phase is where you get into this rapid experimentation, because there is no universal learning algorithm. So you always have to do a lot of experimentation to figure out which machine learning algorithm really fits your data. So this rapid experimentation becomes very important. That's the next phase in that journey. Beyond that, beyond the training process, once you have a model identified, a particular model that works really well for your data, you have this tuning step, right? The tuning step is also rapid experimentation because you're exploring different hyperparameters which influence the model, how the model learns, how the model performs. So you're essentially doing rapid experimentation for the model you picked with different configurations, right? And that's essentially the tuning phase of rapid experimentation. And beyond this phase, you are getting into the deployment phase, right? And operationalization phase of machine learning. The deployment phase focuses on really extracting the value out of the machine learning model. So essentially, you take the model that you trained and tuned, and you put it in production as an endpoint, or you use that model for inferencing data in a batch mode. So that's where the value comes through, right? So that's where the business value comes through. Beyond that phase, you now get into this operationalization phase where you figure out all this recipe, and you have to make it work, make the models meaningful on a periodic basis, keep them refreshed, keep them relevant, make sure that there are no drifts in production. So that's the last phase of operationalization, model monitoring, and all those aspects. It's a circle of life. Again, it comes back again. In production, when you're monitoring the models, you may be experiencing drift in quality. You may have to address the drifts. So you again come back to the business problem and try to understand, hey, what is this drift about? Do I need to enrich my data, start all over again? So it's a circle of life. So it's an iterative process.
Yeah, and I mean that actually explains a lot. And I was wondering, you mentioned that the hyperparameter tuning, and I wondered if you could talk a little bit more about that and how our customers are using that today.
Yeah, sounds good. So I'll use an analogy to really explain what hyperparameter tuning is all about. So you walk into your favorite restaurant, and your odds are that you always will go for that one item in the menu which is your favorite, right? So it's because you have evidence that that particular item has given you a quick reward, right? That exploit it's an evidence that you can exploit that to get a quick reward. So there is always this conflict of exploration versus exploitation, right? So do you really want to go for a new item in the menu? That's exploration. There is risk in it. It may end up being your best favorite item going forward, but there is also the risk that it may not turn out to be good, right? So there is always that conflict between exploration and exploitation. So tuning also deals with that. So there's a lot of different configurations that the tuning model tuning process goes through. And across these configurations, there's a lot of exploration. how do you really get to the right configuration that gives you the best model is all about tuning process. That is where the exploration and exploitation techniques come into play. There are different exploration and exploitation techniques that are adopted in tuning process, and that's really where practitioners focus. They really try and understand their use cases and understand what explore exploitation strategies work for them and how best they can employ them. I mean, that's where SageMaker automatic tools like SageMaker Automatic Model Tuning, which kind of automates a lot of science and orchestration behind the scenes on behalf of our customers, comes into play.
I love that. And ironically enough, I was, as you were talking and explaining hyperparameter tuning, Lazy Coder 3 was reading my mind. Thank you, Lazy Coder 3, because I've used Deep Racer, and Deep Racer, for those of you who haven't used it, it's a fantastic way to start learning about deep learning, specifically reinforcement learning. But in terms of the topic of hyperparameter tuning, I think it's also a great way to really understand how that part of the machine learning training process works. So you should definitely check it out. And I think for those who still maybe are not quite grasping how this concept works, I think a demo of SageMaker Automatic Model Tuning might help kind of solidify these concepts. So is there anything that you could show us?
Yeah, absolutely. Before I show, the Sage hyperparameter tuning, I want to double click on the hyperparameter tuning. So whenever you deal with model tuning, these algorithms have a lot of different parameters, like how fast do you learn, how do you regularize the learning to avoid the problems of machine learning, the overfitting and underfitting, right? So all those things actually are part of the hyperparameters that you need to figure out. And those constrain the learning so that the model doesn't overfit or underfit and learn something bad from the data. So automatic model tuning offers 3 different strategies. So as I step through the code, first let me explain the 3 different strategies. I talked about the explore, exploit techniques, right? So all the 3 different strategies that the automatic model tuner offers is about different ways of exploring and exploiting your hyperparameter space. So there is random search option where you randomly search the hyperparameter space. Like hyperparameters could be many hyperparameters, like learning rate, regularization parameters, and all that. So it randomly searches across those hyperparameter space. That's one. The second strategy is the Bayesian optimization, which is the default strategy in our hyperparameter tuner API. And that strategy focuses on searching for evidence. Going back to that restaurant example that I provided, you always order that favorite item in your favorite restaurant, most likely, right? Because you have evidence that particular item has given you a quick reward. So essentially, Bayesian optimization also works in that fashion. So it actually looks at evidence for selecting the next best candidate. So as it actually explores the hyperparameter space, that's what Bayesian strategy is about. The third recent strategy that we launched recently is state-of-the-art strategy, where it's called multi-fidelity, and it's powered by an algorithm called Hyperband. What it does essentially is it combines a lot of low fidelity evaluations with really high quality, high fidelity evaluations, and runs the high fidelity evaluations to completion while stopping the low fidelity ones early. So the low fidelity evaluations will be stopped early, and all the compute resources will be diverted to the high fidelity evaluations. So essentially the net of it is you get a better time and cost profile. So faster tuning, up to 3x faster tuning is what you can achieve with Hyperband. There are certain caveats, like Hyperband is only suitable for iterative algorithms like neural nets, where you can actually look at intermediate learning patterns, and the Hyperband can make decisions to stop those explorations early. So I'll stop there. You have any follow-up questions on that?
No, it just sounds like this can save you a lot of time. And for even new folks coming in, it seems like this could help set you up for better success, as you're starting to learn.
Yep. So what I have shared on screen is how quickly you can actually use hyperparameter tuning API to launch tuning jobs. So essentially, this is the interface to actually define all the configurations that will encode the tuning characteristics of your job. So the estimator, the model itself, right? By now the training has been done. So you give the pre-trained model to the tuner, and then you actually define the objective metric. You specify the hyperparameter ranges. So the hyperparameter ranges could be any of these. So any of these, this is the regularization parameter. This is the batch size that influences how the neural network learns in this particular case. So you are essentially exploring the hyperparameters in this space, in this grid, right? So here, you beyond the hyperparameter ranges, you specify the metric definitions, the constrain the parallelism, constrain the number of jobs you want to spin. So all that is allowed through the tuner API. Once you define all the specification, all you need to do, it's super abstracted. All you need to do is call the fit API. And behind the scenes, what SageMaker does for you is we spin up a tuning job, and what underpins the tuning job is several different training jobs. And all those training jobs explore different spaces in the hyperparameters hyperplane. So those different spaces, those different exploration threads, one of those is the best candidate, is the best version of your model. So essentially, all that heavy lifting, orchestration of spinning up all those multiple training jobs, finding the best one in that across those multiple training jobs is done by Automatic Model Tuner. This is just a gateway into leveraging all that goodness.
So it doesn't sound like there'd be any reason why you would not want to use this, but maybe there is that maybe I'm not aware of. So could you tell us if would there be any reason why somebody would not want to use this?
Yeah, I mean, if there is a strongly defined structure to the tuning problem, right? So if some practitioners are really aware of the structure of the tuning problem, so in that case, they actually specify the hyperparameters manually, right? So you really, I mean, if I go back to this, you really don't need to search. If you are if you know the structure of your problem, you don't really need to search through these hyperparameter spaces. You know what regularization parameter to use. You know what batch size to use. So in those situations, extremely rare. In those situations, you may skip tuning. But again, it all depends on a lot of different factors. You need to understand the structure of the problem. You need a lot of experience to understand what will work and what will give you the optimal model.
Yeah,
almost always it doesn't hurt to run the tuning. I mean, I always see practitioners taking that extra effort to tune the model, and even 1% of improvement in accuracy means a lot to the business value.
Yeah, you bring up a really interesting point, that there are practitioners who want to be able to finely tune the model, but there's probably some other people who maybe, especially if they're new and they're in a job where this is their first time using machine learning, and you're at a startup, you've got to actually implement machine learning into your business. So do those people who are maybe brand new and they just want to get their first model into production, do they need to understand how the search strategy actually works?
Yeah, it helps to understand how the search strategies work. So if they're using the default search strategy, which is, I mean, in this particular case, I did not specify a search strategy. So by default, I'm actually picking up Bayesian, which looks at evidence in my past trials and picks up the next best sets of candidates. But if you want to pick Hyperband, for example, which is the state of the art that we recently launched, you may want to have some intuition about how that works. So that way you can really choose the right strategy for the right use case. So there is no silver bullet here. So often you may have a very small hyperparameter space. The random search might work really well because random search is extremely parallel. It can actually launch all the explorations parallelly, and pick one of the exploration as the best candidate. So having that intuition to how these strategies work will help. But to get started, using Bayesian or random would not really demand a lot of expertise in how they work. And that's
So
what we managed to abstract in our automatic model tuning service.
got it. So you brought up the hyperparameter search strategy, and I was just curious because I actually don't know if you could maybe explain a little bit more about what does a search strategy actually mean?
Yeah, so I can explain it with an infographic, right? So if you look at this bottom section of this, right, uh, all these different curves that you're seeing are different explorations, are different training jobs, if you may, that underpin the tuning job. And these training explorations are exploring different spaces in the hyperparameter hyperplane. And at the end of this tuning process, you will figure out one of these threads as your best model. So if you look at this particular bottom section of this infographic, this one is a random search. So it's a spray and a pray kind of an approach, right? You randomly select certain hyperparameter ranges, you train the model candidates, and you hope that one of them gives you the global minima, meaning gives you the optimal model. But if you look at the state-of-the-art strategy that we launched recently, which is the multi-fidelity, it has also it is also doing a lot of exploration, but it is doing the exploration very intelligently. It is actually looking at the intermediate learning curves. It's not really waiting for all the explorations to run to completion. It's looking at the intermediate learning curves. If you see those X's there, it is actually early stopping those unpromising trials, unpromising explorations, and diverting all the resources to the promising ones. If you see the longer lines in this curve, in this infographic, they are the promising exploration, the high fidelity explorations. That's when we combine these high fidelity evaluations with low fidelity evaluations and give you that very good balance of optimizing the compute resources to be used for the meaningful evaluations.
Yeah, there's
So
definitely. Oh, go ahead.
I hope that kind of gives you an intuition of the different strategies and why the choice is important.
Yeah, no, it definitely helps to see it like visually. And there's a couple things I wanted to call out because for those of you who missed in the chat, we actually have some links to hyperparameter tuning on GitHub. So you should go definitely check that out. And there's also thank you. We've got a self-placed blog. There also is a specialist in the chat, a machine learning specialist. So if there's other questions that you have and maybe just haven't gotten to get answered, make sure you drop them. So from here, where do you think that people should actually go next if they want to learn more about automatic model tuning, explore different search strategies?
Yeah, we have a webinar coming up on October 24th, and that webinar will actually give a deeper understanding of deeper overview of the product and what it brings to the table. And we also have some launch collateral, which my colleague will share in the stream chat. And I guess that's we can take it from there.
Perfect.
I hope you're going to present this image in that the webinar that you're doing, because this is pretty impressive of the capabilities and just how much butter and how much time this must save for new folks, and also for folks that already know what are been working with machine learning for some time.
Absolutely, yeah. Thank you for having me on the show.
Thank you so much.